clock starts. So let's start our session. First, Shahil Varman, you can start your presentation. Representing your screen.
Yes, sir. Yeah, I hope my screen is visible.
Yeah, screen is visible. You can go to the presentation.
Hello?
Your screen is visible, Shahil. You can go to the presentation.
All right. Yeah. So my name is Sahil Varman, and today our presentation will be regarding a hybrid reactor design for enhanced food waste anaerobic digestion using granular activated carbon. So the basic introduction to this experiment, I will first walk you through what the design is and what the process is, and then I will explain to you the experimental protocols as per us. So the annual production of food waste, as we know, is increasing with the population growth and urbanization, and that's why we should ensure the proper handling of this food waste. And to ensure this, it does not become an environmental hazard. So the biomethanation, as we know, is an established gold standard method for food waste treatment. Since the macromolecular organic matter, which is suitable for this, is perfect for anaerobic microbial growth. This process is which in a process in which organic waste is biologically degraded into methane-rich biogas. But somehow the intermediates of the anaerobic digestion inhibit, would you call, the process. And instead of this, we should use it and receive products that are economically viable. So anaerobic digestion a sequential biochemical process in which complex organic components such as polysaccharides, lipids, proteins are hydrolyzed or broken down into intermediate products. These intermediates later are oxido-reduced into methane and CO2. And we are going for anaerobic digestion because it requires less energy and produces less sludge compared to as the aerobic counterpart. So the anaerobic digestion basically revolves around four phases, which is the hydrolysis, acetogenesis, and the methanogenesis. The methanogenesis is basically the crucial part where we want to emphasize on. So now moving on, we will be concentrating on the total soluble products which are produced during this. The TSP includes the acids, alcohols, and solvents. The VFAs or volatile fatty acids is one of the key total soluble products that is used for the production of high value added products. These accumulation of the VFAs in reactors reflects a kinetic imbalance between the production and consumption rates, causing acidification. So now moving on to what materials and methods we have employed in our experiment. The substrate and inoculum. So the food waste substrate was collected from the BITS Pilani Hyderabad campus hostel mess. So we tried using basically what is already present instead of making an artificially prepared food source. So the inoculum was collected from a full-scale anaerobic plant treating food waste and fed in a 1:2 IS ratio. To improve the efficiency of anaerobic digestion of food waste, a 0.05 gram per TSS of GAC was added. Experimental setup and operating condition. So So basically, we used 130 ml serum bottles were operated in mesophilic conditions. So now I'm going to walk you through the basic methodology. So we collected the food waste and the inoculum, and we first ground the food waste and then mixed it in a ratio. Now the serum bottle without GAC and there's a serum bottle with GAC. So after this, we divided these two steps by characterizing them by the TS, VS, pH, COD, BOD, PK, and TP, VFA analysis, etc. And now we will be able to compare these two different steps and whether or not the GAC was able to have any whatsoever positive effect on the digestion. Now, GAC is basically a carbon-based conductive material. The conductive material serves as a conduit for electron conveying, provides the habitat for microorganisms, and offers additional buffer capacity. So, carbon materials commonly used for biomethanation, like we said, are GAC or biochar hydrochar. Carbon felt also is very popular recently, and graphene oxide, and carbon nanotubes too. The large surface area and honeycomb porous structure of GAC enhances the VFA consumption by methanogens and serves as a perfect habitat for microorganisms. Moving on. So the effect of VFA concentration on biogas production. As we can clearly see on the 11th day, the would you sorry. Okay, yeah. On the 11th day, as we can clearly see, among the other VFAs, acetic acid serves as a vital substrate for methanogens, and an overabundance of it can cause acidification and decrease methane production. To ensure that this does not happen on the 11th day, if we had GAC already installed, it would probably help. So, moving on. Effects of VFA concentration on methanogenesis. So basically, the domain of archaea, as we can see, is 6.4% initially. SAR, it's just 0.4%, and healthy is 4.2%. Whereas in the bacteria's case, it's 92.2% initially, but SAR is 91.1%, 95.2% healthy. So this can have a very detrimental impact to the VFA concentrations, causing acidogenesis down the line. So to curb this, GAC would be vital to our process. So now moving on to the direct interspecies electron transfer, or DIET for short. It is formulated by contact of cell to cell or cell to conductive materials. The conductive materials affect basically the ecology of the anaerobic reactor, causing physiological changes in the microbial biota, increasing the cooperation between the electron donating and accepting. The interaction finally can be between biofilm and the suspended cells. Now here the GAC comes in and improves the syntropic relationship between microbial consortia and serves as an electron acceptor and even a donor during the biomethanation process. As we have discussed before, this is probably due to their high electrical conductivity and specific surface chemistry with the honeycomb structure. Moving on, the characteristics of GAC, we are looking at a particle size of around 0.4 to 1.2 micrometer. The approx pore volume is around 0.97 centimeter cube per gram, and the approx surface area is around 950 to 2000 meters square per gram. Due to the high degree of microporosity, this GAC exhibits excessive surface area, which is perfect for the microorganisms. The improval of syntropic relationship is thus so. Now, the GAC provides resistance to unfavorable conditions, and the anaerobic reactors supplemented with GAC showed resistance to high organic loading conditions than conventional reactors. The shortened lag period of anaerobic digestion even under conditions of high hydrogen partial pressure, and finally a resistance to low pH for attached cells on biomass support media, which is crucial, especially in the acidogenesis we had seen in the 11th day. So the enhancement in methane yield and enhancing system stability is one of the reasons we employ GAC in our processes. So basically, I would like to conclude now that the biomethanation of food waste is a complex biological process prone to failure as it is very dynamic, and if not properly managed, it can fail. The addition of GSC, we have observed, enhanced biomethanation of food waste by increasing the organic removal, the biogas production rate, the reduced lag phase in biogas production, and most importantly, high methane yield, which in future can have a lot of economic viability. I apologize for the typo. Among conductive materials, GAC is considered primarily a diet activator due to its economic feasibility, high durability, and finally the easy accessibility. Thank you.
Yes, Shantanu, a good topic. Actually, it's a very important topic. You have wonderfully managed all the organisms, right? You came out with a variety of organisms, methanogens. Have you isolated these all organisms?
No, ma'am, we have not isolated any mechanisms.
So, from the food,
We
have you characterized the organisms? How did you develop this table completely without characterizing? You cannot say that organisms name, right?
we had done some literature survey and came up with these. The PhD students in our department have been working on this, so we took some data from them.
Okay. You actually use that biochar. So that biochar, have you characterized that biochar?
Ma'am, we are not working with biochar. We are only focusing on GAC.
Yes. You use that
Yes.
for the process. You use biochar.
No, ma'am, we have only used GAC in our process.
Show that biochar also enhance the product development.
Okay, ma'am. Okay, ma'am. Yes, ma'am.
But it's not clear. You are not characterized that because no, it's a very complex process. And managing these microbes, that combination of materials, that organic compounds, and also the environment, what you are providing, anaerobic digestion is a very complex process.
Yes,
So
ma'am.
in that, if you are giving that sources imbalancedly, you cannot achieve that product finally. You cannot see the growth of the organisms. If you are imbalancedly overload that biochar or overload that conditions, you cannot achieve the product as
Yes,
literature
ma'am.
shows. So that must be very clear and it must be balanced. And before starting the process, you should characterize whether it's suitable for the survival of your organisms.
All right, ma'am. Ma'am, but I think there was a correction for us, ma'am. I think we just mentioned 4, 5 graphene or biochar, just for the knowledge, but we have only employed GSC in our experiment.
Okay, otherwise you should not include, right? So if you are short, you have to be clear with that area. And if you
Yes,
are
ma'am.
adding that ratios and that balancing, the conditions, environmental conditions, and the parameters, everything must be very
Strict.
standard. Otherwise,
Yes,
if it raise, you may see that failure sometimes. So
yes,
that's
ma'am.
very important. Otherwise, that process is very good, and food waste utilization it's globally is wanted, and like our Indian country, actually people are managing this food waste and converting as energy is a good topic, but more concentration is required to balance the conditions to come out with a good yield.
Perfect, ma'am. Thank you so much for your valuable feedback. We will definitely look into it.
Thank you.
Next participant. So next participant, are you ready for the presentation?
Participants for general discussion, please make your presentation within 5 minutes. Avoid the introduction and all. So since we are in time constraint, so I request all the presentation participants to complete the presentation within 5 minutes, and we have another 3 minutes for discussion. Expect your cooperation in this regard.
Okay, next we call upon Ms. Nivedita for presentation. Present your screen, ma'am.
Sir, my screen is visible.
Yeah, you are.
Sir, now my screen is visible.
Your screen is visible. Please make sure your mobile is in landscape mode.
Yes, sir. I'm Nivedita. Nivedita, today my presentation on regarding process optimization of microwave assisted extraction of polyphenols from underutilized alum peel. The introduction is the natural bioproducts have recently received attention for their extraction of bioactive compounds from plant cells, as extracted bioactive compounds have a greater ability to promote human health benefits. Alum belongs to the family of Amaldaceae. It has been used as a food and medical crop since ancient time. It has a promising beneficial properties such as antioxidant, anti-inflammatory, antibacterial, anti-cancer, and anti-carcinogenic. More, they also possess several phytochemicals and rheological properties. The objective of the present studies were to study the effective of operating parameters on microwave assisted extraction of polyphenols from the onion peel. The socio-economic value of the project is to develop cost-effective strategies for extraction of polyphenol from onion peels, elucidate the potent medicinal properties of polyphenols extracted from the onion peel. The workflow of the project is first plant materials were collected and solvent system for the extraction was screened. Then the effect of process parameters on microwave assisted extraction of polyphenols are content. The optimization of process parameters for microwave assisted extraction of polyphenols. The methodology is first sample was collected near Ramanath district. And peel were dried, powdered and sieved and stored for further use. The extraction using different solvents. First, the dried powder was taken and extraction with different solvents used such as water, ethanol, methanol, acetal, and hexane using microwave extractions. The process parameters used were microwave power, irradiation time, and solid liquid ratio and pH. First, optimize using one variable at time. Approach is a multivariant and conventional technique used for the optimization of the process variables. The process variables were optimized in a subsequent manner. But first, we take a solvent and liquid to solid ratio to 10 to 60 ml. The time is between 30 to 330 seconds, and the pH is between 5 to 11. The microwave power is between 90 to 630 watt. The optimization of Cosmo using the response surface methodology was done using central composite rotational disk. In this, 30 runs were performed and 4 variables were fixed. The statistical analysis done using Design Experts statistical software package. The experimental data was analyzed using multiple regression, and the significance of regression coefficient was evaluated by F-test. The modeling was started with the quadratic model, and the interaction terms and model adequate were checked in terms of the value of R square adjacent R square, and the prediction error sum of squares. The significant terms in the model were found by Pareto analysis of variance. For each response, an ANOVA table were generated with the factors unique. The results was the different solvents from the different solvents cleaning. I got maximum phenol content at the water, so I take water as a solvent for further studies. So if I take for microwave power, I other parameter as tan, I changing the microwave power. From this, I have got maximum phenol content at 560 watt power. And then I change the time. In this, I have got total phenol content in 150 seconds. When I change in the pH, I got maximum phenol content in pH 10. Then when I change in the solid liquid ratio, then I got maximum phenol content at 40 ml per gram. Then in the C3RD, the extraction of total phenol from alum cibopyl was investigated using the 4 different process variables such as solvent, concentration, liquid solid ratio, microwave power, and irradiation time, using 4-factor 5-level of central composite rotatable design. From this, I have got maximum phenol content at power 540 and time 150 seconds, and solid liquid ratio at 30 and peak at 9. From this, I have got total phenol content at 77.27 mg per ml. From the ANOVA table, the highest F value and the lower P value demonstrating the significance of coefficients. Its corresponding lower P value and CV value, the adjacent R square value ensuring the best fit of the model was effective and feasible to recovering the highest yield of polyphenols from alum cibopyl. The response surface methodology was applied to understand the interaction relationship between the test variables and to identify the influence of selected process parameters over the yield of total phenol content. The three-dimensional response surface were illustrated in this figure. The effect of microwave power and irradiation time, pH, a liquid to solid ratio on total phenol content illustrated. From the diagnostic plot figure, the experimental value are compared with the prediction value of the developed model. In the developed model, the data lie close to the straight line, which indicating the high correlation between the experimental data and the predicted data. The data were evaluated to analyze the normality of the residuals. The residuals give the difference between the observed value of the response and the value that is fitted under the theorized method. Small residuals were denoted the model prediction is accurate. In normal probability plot, the data point lie close to the straight line and the residual values were also small, which indicate that the data point were distributed normally and the development model is accurate. From optimized condition obtained from the developed model, I have got maximum yield of phenols obtained at the power 540 watt, pH 8.6 and time 158 seconds, and solid liquid ratio 31 ml per gram. From this, I got total phenol content at 77.16 mg/GAA per gram dry weight. Our future work is the focus on the characterization of the extracted the bioactive potential of phenols, certain anti-cancer effect of extracted biophenols. The study will also focus on the characterization and evaluation of the residual biomass obtained from extraction of biophenols from the plant source. Thank you.
On what basis you have selected this parameters for the RSM process?
Ma'am, I can't hear you.
On what basis you have selected the parameters for running the CCRD model? You have generated
Based on the
right?
yes, ma'am.
Random surface methodology. You adopted this random surface methodology, right?
Based on the it's based on the one variable at a time process, ma'am.
On basis of
One variable at a time with changing in one. We each parameters we have tested, ma'am. Then we have taken the RSM for that.
okay, now in that 3D you have shown only for the three factors. One factor is missing, I think, for 3D.
Okay, I will see. Okay, ma'am, I will see, ma'am.
Okay. Actually, in the what run, actually you have run this 20 runs in the RSM, right? Predictions,
Yes,
20
ma'am.
runs. So in that which run it showed that 77.
Hello.
You got that the final product, what is the yield of your product?
And the final yield product 77.16 something, ma'am.
So that is actually you already, that statistical prediction is there now. So in that which run is showing that 77.
Which I mean the run is fourth run, ma'am.
Fourth run.
5 4.
Can you show me that? Some of ANOVA is not clearly showing the screen.
Okay, ma'am.
Can you show that?
Okay, ma'am.
Fourth run. Okay, Nivedita, carry on. But no, that statistical data and choosing the parameters preliminarily you have to do with the classical pattern. So based on that performance, only you can choose that what are the parameters and factors influencing that product yield, grade yield. Okay. So based on
Okay,
that,
ma'am.
you can choose for your son. Okay.
Okay, ma'am.
Next participant. Eva Priya, are you ready for your presentation? Their absence. Next, Sujita. Sujita, are you audible? Can you hear me? Sujita, yeah. The next, Venkatachalapati.
Sorry, sir. Am I audible, sir?
You can start your presentation by presenting your screen.
Okay, sir. Just connect the.
Yeah. Presenters, you are lacking of time. Please make your presentation as shorter.
Hello, sir. Shall I present, sir? Sujita.
Please wait. Next to you can present next to the Venkatachalapati. either wait until Venkatacharpati.
Sir, excuse me, sir. Am I audible?
Yeah, you are audible. You can present next to Venkatacharpati. Please be ready with your presentation. Venkatacharpati, are you comfortable presenting?
Yes, sir. Yes, sir. Can I present now, sir?
Yeah, start your presentation.
Okay. Good afternoon, honorable present here. I'm. Okay. Good afternoon to honorable present here. I'm very pleasure to present my work here. Um, I'm doing my project in CSIR at the National Institute of Oceanography. My project topic is characterization of sewage using biochemical and molecular tools. Under the guidance of Dr. Catherine Manohar, Principal Scientist, Biological Oceanography Division, and Dr. J. Sheila, Associate Professor, Department of Biotechnology. Introduction. Marine macroalgae have a significant potential as an alternate source of biochemical substances since they have multiple distinct metabolic processes. In this study, exact glucose, dried and fresh samples of 15 series were analyzed for pigments, antioxidant activity, protein, DPC, lipid and carbohydrates. When compared to the dried samples, fresh samples have higher antioxidant properties for these studies. This research will aid in understanding the biochemical makeup of local seaweed species for commercial purposes. These are all the samples I have used for this, like rhodophyta, pheophyta, and chlorophyta. This picture is shown by shared rate samples using a homogeneous method for further experiment. And the second picture is for fresh samples. Then it involved to be dried for 6 days. And then my objective is quantification of proximate content in representative red, brown, and green macroalgae. And the second is change in approximate content in fresh, shared rate, and macroalgae samples. And then molecular characterization of the macroalgae. Then sample preparation. Fresh sample have been obtained from the various locations. However, they must first be dried for 6 days before we using as studies. And shared rate sample, 2 gram of sample can I take and mix with 20 ml of water, sonicated method sonicate for 10 minutes. And each tubes have centrifuge at 6000 rpm for 6 minutes at room temperature, and then collect the supernatant that will extract. And then go for methodology. Proximate content in this sample like carbohydrate, lipid, and lipid, total phenolic content, chlorophyll A, B, and carotenoids. The total sugar has been measuring the using phenol sulfuric acid method, absorbance at 490 nanometer. Reducing sugar has measuring the DNAC method, absorbance at 540 nanometer, and estimation of protein in these samples using for Bradford method, absorbance at 595 nanometer. Total phenolic content has measuring for the FC reagent, absorbance at 765 nanometer, and lipid has treated with chloroform and methanol 2:1 ratio concentration by Folch method. And chlorophyll A, B, and carotenoids has been measuring with methanol absorbance at 3 different nanometers, like chlorophyll A, like this formula has used, and scavenging activity like DBPH and ABTS. This is a formula of scavenging activity, control minus test divided by control into 100. And these are our results for my samples. Total sugar is this, and my considerable sample have been used for shared rate sample is most compared with fresh sample and shared rate sample have comparing the most total sugar, reducing sugar, protein, phenolic content is high peak. And the pigments also. Pigments is most used for most high peak in shared rate samples. FEX means fresh samples is compared to lowest this, and the lipid also, and the antioxidant activity. Then this that is also most high peak in shared rate samples. Then conclusion, fresh sample compared with the fresh sample compared to the shared rate samples greater than biochemical content and proximal content produce even the fresh sample up to the 75% of dry weight. And for comparative proximate and proximate on the sample for the commercial applications. Thank you, sir.
Molecular characterization what you have done on the molecular characterization.
I'm not clearing.
Molecular tool. Your title actually you mentioned this characterization, biochemical characterization, and molecular tool.
Yes, ma'am.
What
Yes,
you have
ma'am.
done?
Just doing a DNA extraction, then it will going for the gel preparation, PCR running, and agarose gel electrophoresis, then going for the sequencing for functional genes in antioxidant activities. In antioxidant activities.
And Rhodophyta, these blue, green, algae, brown algae, every algae is having this all, and then everything is known. No need to go for, as a research, you don't need to go for characterize these biochemical characters, it's already known, right?
Yes, ma'am.
And then why should you go for any, if you are taking a project for the application part, because unexplored activity, any activities are not known. So if you are taking for the activity study, not that time utilization is okay. If you are spending your time for applying that algae in any of the field, like metaphysics or food, if you are converting that materials, these all of the constraints. By using that, if you are applying for any medical purpose, if you are spending your research time on that, very useful. There is no uniqueness in your part. Your presentation part is every data is already published, already known data. Okay.
Not like that, man. Not like that, man.
And also you have to give a clear picture about that algae. Algae is three images. If you are giving that images clearly and that classification part, that all algae is coming under this exactly, if you are showing that, that may be the message to the participants of that. Okay, improve your activity. Other than this characterization, if you go for that, with that use, you apply your mind and take it for the many of various field applications. Okay, all the best.
Okay, thank you.
Thank you, Venkatacharya. Next. Participants, there is an humble request. We are lacking on time. Please simply explain your theme of your lecture. Next, I call upon Ms. Tamil, Ms. Sujita for their presentation. Sujita, are
Good
you
afternoon, sir.
online?
Yes, sir.
Yeah, present your screen and start your presentation.
Okay, sir. Good afternoon, sir. Good afternoon, ma'am. My topic is responses of to antidepressant drug fluoxetine toxicity, assessment of antioxidants and inorganic ions. My name is M. Sujita, PhD Research Scholar, Department of Zoology, Avinashilingam Institute of Home Science and Higher Education for Women, Coimbatore. My guide is Dr. K. Manimegalai, Professor and Ed. Introduction. Pharmaceutical pollution is a major threat to aquatic ecosystem globally. Antidepressants are one of the most commonly prescribed drugs in human medicine, so it makes sense that they would be one of the most frequently found compounds in the aquatic environment from all pharmaceutical classes, with concentration ranging from nanogram per liter to gram per liter. Some of the most common antidepressant drugs including fluoxetine, fluvoxamine, and sertraline. These are SSRIs, selective serotonin reuptake inhibitor, which act by blocking the reuptake of the neurotransmitter serotonin from the presynaptic nerve club. Serotonin is an important neurotransmitter present in highly complex organisms such as mammals, as well as in lower vertebrates and invertebrates. Fluoxetine is a selective serotonin reuptake inhibitor used to treat depression, anxiety, obsessive behavior, and eating disorder in people. Bioindicators. Many reports predict that fish have been widely used as bioindicator in various aquatic systems and fish models are also increasingly used in the early phases of pharmaceutical development and its toxicity evaluation. Furthermore, biomarkers are widely used as early diagnostic tools for aquatic pollution, ecological risk assessment, and aquatic organisms. Among the variety of biomarkers in ecotoxicological investigation, the enzyme activities have been widely used as sensitive indicator of stress in fish exposed to the diverse group of water pollutants, particularly pharmaceuticals.
Sujita, please
Aim and
stop. Go
sir,
to your research slide and explain your research.
methodology, ionoregulatory parameters, sodium assay, potassium assay, chloride assay, antioxidant accident parameters, superoxide dismutase assays, catalase assays, lipid peroxidase assays, glutathione S transferase. Result: plasma electrolytes. Changes in the plasma national sodium levels of fish Labiorogita in the fifth day exposure period when compared to the control it found to be decreased. In 10th day found to be decreased when compared to the control. In 15th day I have found that there is no change. Changes in the plasma potassium level of fish Labiorogita when compared to the control bypassed trend in 5th day. In 10th day found to be decreased when compared to the control. In 15th day decreased in both the concentration. Changes in the plasma chlorine level of fish exposed to Labiorogita. 5th day, 10th day, and 15th day exposure period was bypassed trending throughout the study period. Discussion. In the present study, the significant reduction of sodium, potassium, and chlorine levels were observed to the fish Labiorogita treated with fluoxetine for 15 days. Hence, the significant diminished activity of sodium potassium level may be due to the increased blending of the test compound to the active sites of membrane-bound enzyme has been reported. A significant reduction of sodium, potassium, and chlorine ions when the fish Labiorogita exposed to the mercury at different concentration. Result: antioxidant parameter changes in the gill SOD activity of fish Labiorogita SOD activity in the gill of fish was found to be increased significantly throughout the study period. SOD activity in the liver of fish was found to be increased significantly throughout the study period. SOD activity in the kidney of fish was found to be increased significantly throughout the study period. Changes in the gill cat activity of fish Labiorogita. The cat activity in the gill of fish bypassed trend in 5th, 10th day period. In 15th day period found to be decreased. Changes in the liver cat activity of fish Labiorogita. The cat activity in the liver of fish was found to be decreased significantly throughout the study period. Cat activity in the kidney of fish was bypassed trend in study period. Changes in the LPO activity of fish Labiorogita. The LPO activity in the gill of fish was found to be increased the study period. LPO activity in the liver of fish found to be increased throughout the study period. LPO activity in the kidney of fish found to be increased except 10th period of treatment 2. Changes in the gill GST activity of fish Labiorogita found to be increased except 15th day of treatment 1 period. GST activity in the liver of fish found to be increased throughout the study period. GST activity of kidney of fish bypassed trend in throughout the study period. Kidney. Conclusion. The present study concludes the chronic exposure fluoxetine alter the ionoregulation antioxidant activity in Labiorogita. These parameters could be effectively used as potential biomarkers or biological endpoints in assessing the toxicity of fluoxetine and aquatic organism. The finding of present study also provide a better understanding of toxicological endpoint of aquatic pollutants and to determine a safer level of these chemicals in the aquatic environment to protect the aquatic organisms. Thank you.
Very good, Sujata. It's a very good topic. Wonderful. You have completely assessed all the parameters. What is your final recommendation for this research?
Final. Excuse me, ma'am.
What is your final recommendation to the public from your research outcome?
Then we have to use the safer level of these chemicals to determine protect the aquatic organisms.
Okay, Kanya, good. Carry on your research. Very good research.
Thank you, ma'am.
With the publication.
Thank you. Thank you, ma'am.
Thank you, Nivedita. So next part. So, many participants, please go for your lunch.
என்ன டாபிக் இது நெக்ஸ்ட் பார்ட்டிசிபென்ட்
Go for your lunch. The session will continue after 2 o'clock. I repeat again, the next session will start at 2 o'clock. All online participants, please be joined in this link to present your presentation. And make sure you should finish your presentation in 5 minutes.
ஓகே தேங்க்யூ நான் ஏதாவது சைன் பண்ணணுமா இங்கே வந்து செஷன் ஷேர் பண்ணிட்டு என்ன டேட்டு
Hello, sir. I'm going to present.
ப்ரெசென்ட் பண்ணுறாங்களா நீங்களே மேனேஜ் பண்ணிக்கிறீங்க சரி பண்ண சொல்லுங்கள்
Okay, Roshni. There is a request. You can present now. Your presenting time is 5 minutes.
Okay, sir. So can you wait for 5 minutes? I'm just presenting.
Present your screen. There is lack of time. Please present within 5 minutes.
Roshni?
Hello, ma'am. Can you give me 5 minutes? I'm just presenting. It's a technical issue.
Okay, okay. Take your time.
Okay, Roshni, if you are facing some technical issues, right?
You can present after lunch.
Yeah, you can present after the lunch. There is lot of time after the lunch. So please stay ready.
Okay.
After
Yeah.
the
Okay, sir. To solve that technical.
I'm really sorry for the inconvenience that is made in this session. The participants, please make sure you have to present within 5 minutes. So let me meet in our next session. The session starts at 2 o'clock. We will intimate you in the WhatsApp group. Okay. Thank you once. Have a nice day. Bye. Don't make it good now. Okay. Now I thank Dr. Usha, head of the Department of Microbiology, Dharma Academy and Higher Education, for their support to evaluate our session participants. Thank you, ma'am. And next, I highly thank our assistant professors, Department of Biotechnology, to manage this meeting a possible success. Thank you all. Have a nice day.